On this week's menu, I designed the Dowerl Inserter, the tool swapper. I also installed a camera to surveil my prints. And I finally used some geometric programming to calculate the dimension of the robot. So starting by the Dowerl Inserter, on this iteration, things are actually the right size, so it fits together nicely. The dowels are inserted onto the ribbon, and then are pushed through the tool. I'm happy about this. Next iteration will have the complete inserter, but for this I will need the fixture the tool will be on. Talking about this, I have been thinking of multiple ways of drilling and inserting the dowels, trying to do all of it from the same tool. There is the solution of using the drill bit to both drill into the wood and push the dowel. The main issue with that system is what I always forget: tolerances. The drill is likely to be a millimeter larger in diameter than the dowel, and this would destroy the hole in which the dowel sits, and it may break the ribbon, which goes against reusability. Plus, there is a likelihood of breaking the ribbon in the tool, which would suck. There is a solution of using a more complex tool that would push the dowel in a temporary spot, and then push the dowel in with the drill. In the end, this adds too much complexity at this stage. This is a prototype, and easy is better than complex for now. So, I've designed a piece that rotates and swaps the tool to use. This piece will be lowered into the wood, and the plates at 45 degrees will rotate to choose the tool to use between the drill and the dowel inserter. It should be easy this way to center the tool on the same spot. Easier at least. These were big pieces to print, and I wanted to make sure the prints were going well without sitting next to them. So I used one of those ESP32 camera, which I've set up with motion eyes to track the progress. Yes, duct tape is a perfect tool in all applications. Motion Eye is a software that handles IP cameras on the network. I've installed this in the workshop. It runs on an overclocked Raspberry Pi. The ESP32 cam package is amazing, €5 for an IP camera. Anyways, to make sure Motion Eyes found the camera, I set it with a static IP address, and so I had to set the gateway and the subnet, nothing too complicated. Obviously, the camera doesn't see at night, but that's not the camera's fault. I am going to use geometric programming in order to decide of the maximum size of the piece of wood that fits into the robot. I could simply use some easy math or even common sense to figure this out, but I like to use this geometric programming in order to build a model and iterate over it. At least that's my excuse. The first step before building the model is to set some parameters, like the wood density, the maximum length of the piece of wood, the maximum weight, the formula to calculate the volume of the piece of wood, and then it's just a matter of solving the model. The great thing is when you have multiple free parameters, you can optimize to find the best fit. All of that to decide that the robot will accept between 10 cm and 30 cm width, which makes for a travel distance of 20-25 cm with the drill bit. Great, now that this is done, I need to figure out how I want to rotate the piece of wood around its axis so I can plant dowels all around.